everyone. My name is Stephanie Broxton, and welcome to the Smarter Together webinar series. This webinar series touches upon how multidisciplinary applied research can be used to make a community impact and improve the human condition. This is the first webinar of the fall semester, and the Partnership for Inclusive Innovation is so excited to welcome you back. Before we introduce today's presentation, I have a couple of reminders. Please remember to keep audio and video muted unless you are a speaker on today's panel. If you have questions throughout the presentation, please enter them in the chat box to be addressed at the end of the presentation. Afterwards, we will moderate a Q&A session with the remaining time. With that, I would like to welcome Greg McCormick, the director of the Georgia Smart Communities Challenge, to introduce today's presentation.
Thank you so much, Stephanie. Welcome, everyone. So glad you've decided to participate this afternoon and hear from the first of 4 final project presentations from the Georgia Smart Communities Challenge. This year, we had 4 communities join us for a year-long project in smart communities and technology. This is the 3rd class in the Georgia Smart Communities Challenge now, and we'll be kicking off our 4th class of communities here next month. So thank you so much for deciding to listen in to hear from the Sandy Springs project team this year. I'd like to congratulate the Sandy Springs project team and their Georgia Tech research partners on a fantastic project and all their hard work this year. And you'll get to hear from them today in a culmination of their project. So in summary, thank you for attending and welcome Kristin Westcott and the team from Sandy Springs.
Thank you, Greg and Stephanie. Here in Sandy Springs, I know some people probably have heard a little bit about our project this year, but we dubbed our proposal last year as streamlining suburban transit. And what that actually was a transit signal priority pilot project. Let us take just a couple minutes to introduce ourselves. So I'll start. I'm Kristin Westcott. I'm the traffic and transportation manager of Sandy Springs. I've worked for the city since 2011 and have been in multimodal transportation since the early 2000s. And this actually was my first transit signal priority project. So with that, I'll send it over to our research team, Dr. Hunter.
Hey, yeah, I'm Michael Hunter. I'm a professor in civil and environmental engineering at Georgia Tech. And I do a lot of work in signal control and operations and looking at these types of issues.
Dr. Watkins.
I'm Carrie Watkins. I'm in the same department as Mike at Georgia Tech, but I do a lot of work on transit operations and understanding transit ridership and similar aspects.
And Natalie.
Hello, I'm Natalie Smez-Miegelcook, and I'm with Kimley Horn and Associates, and excited to support on this project in development of an implementation plan.
Thank you, everybody. And really the reason I wanted everybody to introduce themselves was, my last name, right, Natalie? So anyway, thank you, everybody. We are very excited to talk to you today and tell you a little bit more about our project. And just a quick overview, what we did was doing something very different than how some traditional transit signal priority projects are set up. And we focused on one of the more heavily used MARTA routes, MARTA Route 5, that extends from the Dunwoody MARTA station all the way into Atlanta to the Lindbergh station. The actual segment that we looked at was wholly within Dunwoody and Sandy Springs, however. And just a quick blush in case you fall off early, we did find out that what our pilot showed was that it works, but obviously we need to look at it a little bit more closely to ensure we can get the best results moving forward. So let me just explain a little bit on why this was different than customary transit signal priority projects. With a traditional project, there usually is a cabinet device on the roadside at the traffic signal, and there's an onboard unit on a vehicle, a bus. For this particular pilot project, we did not use the onboard unit. We actually used some technology that MARTA has already implemented and related to their vehicle location and adherence and information that they're streaming out of their buses through an API. So that information was sent up from the buses to a central location, which was then communicated to the signal cabinets. And we had two different things going on in our signal cabinets. We have, and these were both investments that Sandy Springs has made in the past and made this project feasible. Over the past year and a half, we deployed an emergency vehicle preemption project throughout the entire city. And that device had the ability to be used for other things. And so we wanted to explore that. In addition, almost 10 years now, the city has been deploying adaptive signal timing through a majority of its system. That system is called SCOOT, and what that does is take real-time information from vehicle volumes in the street with detection, and with that actually makes signal adjustments on the fly. So we set up some parameters in the glance in terms of what we needed to do for priority, needed to meet an adherence schedule. So being behind schedule a certain amount, it had to be within a zone where it was arriving on the signal cycle and not in conflict with our emergency vehicle preemption. And so if all those conditions were met, there were two options. It could be either extend to green or return the signal early to green. So back up a little bit. We had all of the signal side infrastructure already in place to really make this pilot project within Sandy Springs a reality. And so we wanted to see if we could leverage that for more multimodal benefit. In addition, transit signal priority had been identified in previous plans as something to move forward to improve transit services within the city. So the goals of our project really just see if this would work. Would a TSP work with an API as opposed to an onboard unit? We also want to dig down deeply into the impacts on transit and the signal equipment and other travelers. Also understanding the difference between different signal systems. We included a couple signals within Dunwoody. They're operating with a different signal controller, and to make sure that there could be interoperability across lines. As we know, with transit, our transit providers across this region, across many counties and many cities. So to have that interoperability is very important. And then finally, really to figure out how do we move this forward in the future. We couldn't have completed this project without a lot of support from our area transit provider, MARTA, our Georgia Tech research team, City of Dunwoody, our signal support, and moving forward with our implementation plan. I'm the project lead. Caitlin Schenkel was our project manager, and Jim Bunting, our TMC operations manager, provided the technical wherewithal and helping us get everything organized. And honestly, everybody played such a critical role. We had monthly meetings, sometimes weekly meetings as we move this forward. So what did we do? We kicked it off last fall, had to work out some kinks in our deployment plan, but after getting that together, we were engaged with the Georgia Smart program with some discussions about data integration, data availability, as well as community engagement and stakeholders, which really helped us think about how we might utilize our interns for the summer. When in the early part of this year, we set up and configured our devices. We kind of went through all the major testing, really with the deployment in April through June for about 6 months or 6 weeks, sorry about that. The other things that we did related to our conversations about stakeholders and who should be involved, realizing that when we started this study, it was really a technical evaluation, and our discussions with the Georgia Smart program made us think about that a little more deeply and how we needed to involve others in the process. And so working with our interns, we developed an online survey for non-transit riders, as well as had them out in the field looking at bus stops and taking an inventory there. In addition, this summer, we completed some stakeholder interviews. We had the incredible opportunity with our intern and Caitlin to actually go to MARTA's bus garage and interview some bus operators directly. we conducted our virtual workshop, and now we are in the midst of completing our implementation plan. Just a quick note about our 2 interns. The internship program was provided as part of the Georgia Smart Grant, and we couldn't have been happier with the results of collaborating with these young, smart individuals. Our intern Ian had just completed a master's program at Georgia Tech, and he was very much interested in how to work with data. And we kind of gave him at the beginning of the summer this question that came up with our data discussions with Georgia Smart about how do you communicate the benefits of invisible investments. You know, in our world in transportation, people can see, you know, new sidewalks being poured. They can see roads being repaved and the immediate benefit there. It's a little bit harder to see the improvements in a signal system or in technology to improve bus operations because they don't see it. So we charged him with that, and he helped us come up with ways to look at our dashboards and integrate that data to communicate better internally, but also externally. In addition, he helped develop a demo that we used at our workshop to describe what's happening in transit signal priority with our project. Nicholas is a rising senior at Morehouse, and he was very much interested in the human behavior aspects of transportation. And so he worked very closely with Dr. Watkins in developing a non-rider transit survey. In addition, he took place in with bus operator interviews, and both of our interns, we sent them out into the field with one of our GIS techs, and they took on a GIS device and were able to take a pretty detailed inventory at all the bus stops on bus route 5 to look at some of those other factors. Again, expanding the data collection, expanding the stakeholders, and thinking about bus operations overall. And the final task that they worked on together, which was pretty incredible, was to really step back and look at Sandy Springs and what does it mean to be a smart community. So they developed a series of questions and interviewed 17 senior management staff at Sandy Springs, talked about previous efforts in smart communities and smart projects. They also looked at peer organizations across the country and came up with a presentation that they delivered to the senior managers, as well as a lunch and learn and a white paper that kind of lead Sandy Springs forward with smart communities. With that, I'm going to turn it over to Dr. Watkins to talk about why it matters.
So speaking of that survey that Kristin mentioned that Nicholas and I worked on quite a bit, the whole point of this was to try to understand how much of a difference TSP can actually make. We were doing this pilot project, but the whole goal of this is really to increase transit ridership, to understand how these kinds of smaller scale improvements within transit operations could actually mean that more people might take transit, or the people who are on transit would be more satisfied with the experience that they're having. So we did this through multiple things. Marta helped us do a rider survey. We did our own non-rider survey. And as was mentioned, we did these bus operator interviews so we could understand from their perspective what they were seeing on the street. And in the online survey, essentially, again, our purpose was to understand the potential for increase in usage. So will transit ridership actually go up as a result of this? I don't know that we were completely able to answer that, but we were definitely able to get some hints in that direction. So the graphic that's shown here shows the main reason that the respondents to our survey said that they don't use public transportation in Sandy Springs. And as you can see, it taking too long is one of the highest things. Some of these are things that signal priority is not going to change. Proximity, if there's no stops near you, that is definitely a reason you're not going to take transit. But you can see that time and then reliability was 9% of the respondents. And similarly, we asked other questions that got at kind of this same idea of what is it that's stopping you from using transit? And both the time component and the reliability component were very important and were elements that would, that people said if these could be improved, they would actually take transit more often. If it was more convenient, if it was speedier, and if they were able to count on it being on time. Next slide, Kristin. We also dove a little bit deeper into this and asked some questions about how much better does the reliability and the travel time have to be in order to get people to take transit. The respondents generally thought that transit was not reliable. The people who were taking it today, only 20% thought that reliability was we used 5-point Likert scales for everything. So 20% were in the positive side of that. The others were neutral or said that it was not reliable. And then speedy, similar, only 25% said that transit was an efficient use of their time. And the graphics that you're seeing on the right, we asked some incremental things. So if buses were on time 80% of the time, which is an improvement from what is typically seen on MARTA's system, their goals are usually somewhere in the 70-something%. We got improvements, more people who would take transit, but it really took some vast improvements on how on time transit would be before, as you can see in this graphic, we've got 46% said they would probably or definitely yes use transit more often. And then we also talked about, so that's related to on-time performance. We also talked about speeding transit up through things like transit signal priority. And if we were able for the buses to move 20% faster, which was our sort of our higher increment, again, we're getting in that range of around 40% that said, or a little bit higher, that said that they would use transit definitely or probably more often. So there's definitely some gains to be had through these kinds of improvements. Go ahead, Kristin. But then in addition, like Kristin said, we did these bus operator interviews to understand from their perspective, even if we can get more riders, did the bus operators feel that TSP was something that was going to change? And they did not notice our actual pilot. So even though we tested the technology, as you'll hear later in some of Mike's slides, there were some limitations to how much better it was going to get with the way that we were using the technology. They thought that it would be most valuable in sort of this mid-range. Like if you're really far behind, TSP is not going to make a difference. If you're only a little bit behind, you may end up getting ahead of schedule instead, and that's not a great picture. But those buses that are 5 to 6 minutes where they're starting to stress about what the rider's reaction would be, those are the ones that they really wanted to see TSP being used. And then knowing that they can catch up, this is a really important point. Not only could they operate the bus better, but they were less stressed. So it's a better experience for the riders, but they're actually, if they're not the ones who are trying to get on schedule and that the signals are helping them get back on schedule, they don't have to rush. They don't have to slam doors shut and take off before riders have even sat down. If they don't have to have that kind of way of driving, if TSP exists to help them get back on schedule, they can be more relaxed. And this at a time when hiring bus drivers is a nationwide problem because we can't get the staff to do these kinds of jobs because of the high stress levels. And the drivers were also fantastic about giving specific things of this needs to be fixed on the route and this needs to be fixed on the route. And here's where I see delays. And here's other things that we could be doing other than TSP. So it was a fantastic experience to talk to those folks who are sitting in the driver's seat, driving the routes every single day. So I'm going to turn it back over.
Thank you. The next thing we want to talk about is how this pilot is different. And so Natalie will explain a little bit about the different types of transit signal priority architectures that are out in general use. and how this pilot differed from that.
Great, thank you. So Kristin went into a little bit of this in the couple of first slides there, but we wanted to take just a minute to discuss how the architectures are traditionally applied for TSP. So TSP is not necessarily a new technology or way of providing enhanced transit service. However, this pilot project really leveraged some existing infrastructure to do it in a new and unique way. And that's what made it really exciting. So you can think of the architectures in two general categories. The first being central, and essentially that means that the priority generation or priority request generation, so the act of the bus requesting that priority and the processing occur from a central location. So that would be, in this case, MARTA Integrated Operations Center and Sandy Springs Traffic Management Center. And so next slide, please. The second way you can kind of think about it is distributed. And in this case, you have field deployments, field hardware that's in place and manages that same request generation and processing and communication with the traffic signal controllers. And both of these are, sort of being discussed at a simplistic level, but you can imagine that there are so many different ways to configure these. And so within distributed, we have a couple of quick slides here if you want to go to the next one, where all of that processing and generation occurs on the bus and communicates with the traffic signal controller through a request server at the field cabinet, or if you go to the next one, or a connected vehicle. And this is a popular way to do things now, where you have an onboard unit located on the transit vehicle that is essentially responsible for the priority request generation. And then you have a roadside unit, and there's communication between those two to determine when it's appropriate to grant that request. And so, yes, thanks. And so what was implemented with this pilot project was somewhat of a hybrid. And so, as Kristin mentioned, the MARTA bus currently has AVL, so it's automated vehicle location. And so it provides data back to the Integrated Operations Center, and an API was created such that that data was provided out to a central location where the TSP vendor could subscribe and pull that API from a central location, process that. So you can think of this as kind of like translating it into the information and kind of method of communicating within their system, and then sending that back through the cloud to their field monitoring unit. And so as mentioned previously, these field monitoring units were already in place throughout Sandy Springs to provide emergency vehicle preemption. So that really, negated the having to purchase additional field equipment and so forth. All of the existing field equipment could be leveraged to support this deployment. And so that really illustrates why this was such a great way to attempt, pilot, and figure out how to do this in Sandy Springs. So.
Thanks, Natalie. Now we're going to dig down. I know everybody's very interested to find out about what did we learn. And so both Dr. Hunter and Dr. Watkins will give some voice to that.
All right, so let's talk a little bit about the study itself. We've already seen a version of the slide that you're looking at right now. And the only thing to really keep in mind here is to be remembered that the goal of this is not to get the buses through the system necessarily faster or with a shorter travel time. It is about adherence. How well are you adhering to the schedule? So if a bus is on schedule, you don't want to speed it up. For that matter, when we're looking at on-time performance, for instance, the measure being used by MARTA and others is about 5 minutes. If you're within 5 minutes of your scheduled arrival time, that is on time, and no more than 30 seconds over. So it's actually worse in some ways to be early than it is to be a little bit late. So the goal here was looking at adherence. So if a bus is running on time, we don't want to speed it up. So that's really what was coming back. So we're monitoring the adherence. Is it running on schedule? And then only if it's not running on schedule, do you make a change to the signal control by extending the green or returning to green to try to speed it up. So you can jump to the next slide. As mentioned, the system was working. Most of the system is Scoot, and then there's also a couple of traditional intersections. We are looking at the signal system. We're also looking at the transit API, which you've already heard discussed. So we're just going to jump. As you go through the study itself, what we did is sort of kind of control for changes, and instead of doing a large before after and before study and then doing a big after, we actually were able to turn the system on and off, which was kind of a nice way to do it. In that you'd run it have it on for a week, then you could turn it off for a week, and then we would turn it back on for a week, then we could turn it off for a week, so we could kind of see the progression. So you'd have these adjacent weeks, which should have generally similar traffic conditions, and that would really let you see how that test was working out. So it was an on and off system. Now that could create some issues, particularly when we first started up, and it was a pilot study, just try to to make sure the system's working right. And so the first couple of weeks, just a little bit of practice on how do we get it all running when it's not running, kind of get those issues worked out. And that's just part of these studies when you're working at that. But I think we're able to get through all that, and we collected some pretty good data as we went forward. There were also some other challenges as we look at the AVL data and the GPS data that you'll find that when you're working with GPS data, you can have some wander in the data. For instance, particularly the Dunwoody station near the end, we really saw that data, and you can see it on this graph to the far right. All the buses are in that station, but the points themselves they really kind of started spreading out all over the place when those buses were stopped. And part of it's because now some of those buses might be undercover. It's a 3-story building, and they're going in underneath, and you got some of the garage, and you got some of these issues going on. So for that matter, we ended up not even including that station, and we just eliminated the data for that station itself from the final results, because you couldn't reliably say exactly when and where the bus was at that point. Other data becomes issues, of course, that anybody who's worked a lot with GPS data, you're going to see the drift, and you've got to kind of snap it to routes, and the bus is always being monitored. So we have a lot of time where we have data when the bus is actually not on the route, or maybe the bus is not actively picking up passengers. So you got to sort all those kind of data out and kind of look at those issues. So that's actually a big piece of when you want to try to do one of these, is there's quite a bit in looking at the data afterwards and data cleaning on how this works, unless you can really specifically set something up and that's meant to do it. And that's not, we're trying to do this, look at the data afterwards to see how well it worked. So you got to go through that process. There's quite a bit there to do that. You can jump to the next slide. So some of the lessons, of course, we learned is that there's a lot of people involved in this. We're not working in isolation. I'm not, in a little hidden room somewhere. There's a lot of folks involved in the data and understanding the data dictionaries. We're working with MARTA, we're working with Glance, we're working with the AI, the vendors, working with the different counties or cities that are managing the systems. So it's quite a team effort to really put one of these together and to try to get all the data and understand what each person's doing, and just to make the system work. And everybody was fantastic. It was really kind of a wonderful experience. I'll say that as I move forward. But you want to keep that in mind when you're building one of these, is that there are a number of folks who can be involved. And again, the travel time savings, that's not really the goal in the end. It's not about travel time savings. It's about adherence. So if you're already on time, hey, you're good. You don't really have to do much with it. And some of the things we did see, and we'll see this, we talk about a little bit, is this does also now potentially create opportunities for further advancement in terms of, can you, now that you have this kind of data and it's streaming in real time, could you better optimize maybe how you're placing some of the calls? Could you better possibly optimize scheduling and some of these other types of things that we'll see as we talk about later? And also the data itself. This was a temporary data stream that was set up as part of this study, and it had a 2-minute, so it was updated every 2 minutes. And the study, the new system that's going to be coming out will be every few seconds, which will be really nice. That'll give a lot more flexibility to the system and allow it to be, I think, to provide a better optimization. You can jump to the next slide. Main finding, yeah, it works. It seems to work, right? So technically, it all kind of came together, and the system operated, right? The calls were placed, the transitional priority was placed, they were placed when it should have been placed. So it was actually quite successful in that sense. Next slide. So the research questions that were being considered, does it work? Yeah, it does. So the TSP architecture came together, right? We were able to get all the pieces to kind of work together. The next question, you can kind of flip through those. Is it impacting the emergency vehicle preemption? No, it was set up not to do that, right? So the main key of this thing was it could not interrupt that. That was part of the setup. How long does it take to recover in this from observation? It seemed to be about a cycle. We didn't, get in deep and check every single instance yet to kind of go through that, and that'd be sort of some of the future looks at. But it seemed to fairly quickly kind of come back. Does it work across the different systems? Yes, it worked in both the Scoot system and also the existing system on the Dunwoody piece. And is it impacting other travelers? Well, we don't really know that yet, because we haven't been able to collect all that data. We're looking at those pieces. The general instinct is it didn't. We don't think it was, but I want to look at more data before I can say that for certain. On the pedestrians, it didn't, or it shouldn't, because the setup was for this particular system not to interrupt pedestrians. So if a pedestrian had a call, the pedestrian kept the call. You never shorten the pedestrian calls or do anything like that. So you shouldn't see any effects on that side. Was it affecting potentially the other vehicles? Again, because the Scoot was able to return so quickly, it's fairly unlikely, but again, we can dig into that a little bit more as we kind of move forward with the study. Next slide. So what ended up happening in the end? Well, in the end, if we can take a quick look, the yellow lines are the Georgia Tech yellow, right? So the yellow lines are with transit single priority working, and the blue line is when it was not on. Remember, we sort of had this off-on method, and you're going to see it didn't change all that much, right? So let's sort of put that right out there. Maybe a little bit, maybe a 1% or 2% improvement in the on-time performance. And remember, this is about adherence. It's not about moving them faster. It's about adhering. And then the question then is going to become, well, why, right? Why are we seeing what we're seeing? Okay, well, there's a few reasons. One is the current on-time performance, and we talk about the on-time performance and ridership. So let's jump to the next slide. So it turns out that the system, when we were running it, was actually working pretty well prior, without the transit signal performance. You're seeing 80 to 85% were on time, or even a little bit ahead of time, even a little bit early. So you are already at an 85% performance when, by definition, the system would stay off, right? Remember, it only turn on when it had a adherence. It was not satisfying adherence. The bus was running late. So that kind of creates the situation where there wasn't a lot of opportunity to improve. So we didn't get to see a lot of improvement because the system was already working fairly well. It seems to be the case. Now, if you can jump to the next slide. That wasn't the case when we actually planned the study. So if we go back to, well, this would go back as far as March, a little earlier, pre-COVID, the system was running at about 75% on time. So there was more space for the show. It happens for, we can call it a good thing, call it a bad thing, however you want, that just the background of the system, the thing's running about 85% on time now. And that is essentially what happened during COVID. Is COVID the reason? Well, maybe yes, maybe no, we can argue it, but the fact is the bus is running better right now. So when we did our study, we were up to the 85%, so we had kind of lost the space. Part of why, well, jump to the next slide. You can look what happened. We were all here, we all saw it. We had COVID. So you've seen a drop in the number of people riding the bus. This is the bus ridership daily. This isn't for this one is not for this particular bus, but MARTA ridership, it's down. It's down to about 60% of what it was. So you now have fewer people getting on and off, and that's really going to help the buses out in terms of staying on schedule. So that is a potential. I can't prove it because we weren't counting that before, but clearly the ridership has gone down. We do know that for certain, and the buses has become more on time. That's just sort of the nature of what we're dealing with. Go to the next slide. Some other reasons that we're probably seeing what we're seeing is because you also have Scoot, which is working out there on most of this, which is an adaptive signal control system. And the way that's going to work is that now it's going to be responding to whatever the traffic is at the moment. So even though, say, during COVID, maybe your traffic flow or parameters are changing a little bit, this should be providing you an optimal system, which is great. I mean, that's a wonderful advantage, but it also is going to reduce a little bit the flexibility in making the improvements, right? Because you're already running something that's going to be a fairly optimal. So you've got the buses already running 85% on time or early, and then you have an optimal system, so you're going to have a little bit less space to move things around. And you can go another slide. There was also, at the same time, this was sort of unbeknownst to us, we learned this as we were moving forward, and it's a great thing, but it ends up confounding your study a little bit. There was a large push over the last 8-9 months on the MARTA side with their bus drivers to get the buses to be running more on time. They were really working with their drivers and doing some additional training. What can you do to help, either if the bus is running early, kind of drag the line a little bit. If the bus is running on a little bit late, how do you sort of make up that time? So they were also sort of independently out there really trying to make the driver at least not be a source of a potential delay in the system. So the drivers had been working very hard. So now you sort of have the secondary thing going on, which is bringing the buses back online, bringing the buses back on time. And that's going to have sort of this interesting impact of, what is on time. They don't want to be early. They can't be more than 30 seconds early. That's a big catch. So they're probably, if they're within a couple minutes and they do have a real time, they do know how they're doing on time, they're going to be good. They're not going to be trying to make up a lot of time if they're within a minute or two. They're really going to be only trying to make up time if they're way behind. But that pretty much puts you right where our data set was. So if the TSP was allowing it to make up a couple seconds, well, a couple minutes, you're going to see the bus drivers, in a sense, you're kind of balancing out what they were doing already. So it's great in the things that Dr. Watkins was talking about, what Carrie was mentioning with, might help reduce stress and do some of these other things. But it means you're not really going to see it in the results simply because they're working to try to get those couple minutes that you're also trying to provide. So it has the benefit, but you're not going to see it in the data. Next slide. There's also always the potential, right, that there's issues with the data as we kind of dig through. It could be, is there something about how the data is collected and something the GPS. Also, we know we have that 2-minute adherent, the 2-minute AVL stream. As we improve that to get that down to 5 seconds, that's going to really help on when calls are placed, when they really should be placed, and how you handle that. So we can also be working with some of the underlying data, and I think that will help improve the system some. But again, there's just a limit because you're already at 85-86% of these things on time or early. There's not a lot of space to find it, but I do think there's going to be some room, particularly maybe on some other systems where maybe you're at 75% or 70% on time service, where I think some of these data improvements really will prove to be quite useful. Next slide. Is that my last slide? Yeah, I think that's my last slide.
So as Mike is saying, we think the project was very successful from the standpoint of we proved that using TSP in this kind of usage situation was successful, but maybe it wasn't entirely successful when it comes to showing big results in improvements in on-time performance. But there were also some other aspects that we included, and that was working not just with MARTA, but with the regional transit operators to think about how we push this project beyond just this small pilot with those results that Mike was showing. So the consultants on the project, Natalie and folks, did a bunch of one-on-one interviews with the various transit operators. So they met with different departments within MARTA, at the ATL, CabLink, Gwinnett, Perimeter Connect. And then in addition, we had a regional panel and roundtable discussion on August 12th. Go ahead and go to the next slide. Kristen. And from all of those different discussions, from the interviews and particularly our roundtable, we heard a lot of things from the regional transit operators. The first was, as Mike alluded to, in all of this, what we were concerned with was on-time performance adherence. We were only going to give the bus a green signal if it was behind schedule. We don't want buses to get ahead of schedule. But there's a lot more that can be done with TSP and even with other tools. So how do we make TSP the most effective? Well, we can retime corridors using TSP so that the travel time is actually improving in addition to just the adherence improving. But throughout all of this, we need to be balancing the needs of all the modes, including pedestrians. And so that was one thing that we talked about a lot with the regional transit operators. In terms of even implementing TSP, we talked a lot about how difficult it is to have the communication needed between the transit agencies and the jurisdictions. In many, many cases, there's multiple transit agencies within one jurisdiction, or there's multiple jurisdictions that one transit agency is having to work with, and what kind of TSP systems could actually be used in each of these various situations is something that it's going to take a lot for us to investigate further over time. And then the operators also talked about staff capacity, that they need more people who can prioritize these kinds of speed and reliability projects for transit. And that there's so much technology for them to understand that ways to train the staff and make sure that people within the agencies and within the cities know how to use their signal systems to do TSP. These are really big needs for the operators. And they also had connectivity security concerns with the API. So that was discussed as well. Next slide, Kristen. But we also saw a ton of opportunities through the regional transit operators working together. We talked about developing a regional framework for how do we actually prioritize TSP, not just in this one corridor in Sandy Springs, but across the whole region. And then, as I mentioned, adjustments to route times. How do you actually use TSP as one piece of all of this, where we're actually improving travel times and doing other things on routes. Each route has different needs, and TSP is one tool, and the more that it can be used with other tools in the toolkit, improvements at bus stops, fare media improvements, all of these things added together is really how we're going to speed up transit and make it more reliable. And so outside of TSP, we talked about improving bus-to-bus transfers, stop placements, all door boarding, like I said, things related to fare payments, and the physical infrastructure of how bus stops are laid out. And the biggest takeaway was that it needs to be a priority. There has to be a way to have these regional discussions where the focus is on how do we improve transit speed and transit reliability so that we can actually make it an equal player when people are thinking about different modes that they could take for their trips. I think there's one more, Kristen, or is that the last one? There we go. And so I'll turn it back over to Kristen to talk about what's next.
Thank you, Dr. Watkins and Dr. Hunter and Natalie, to present the architecture and our findings and where are we headed. That's what we want to talk about next. It's been such an exciting project over the past year, and I have to say it went by incredibly fast. So what are we thinking about? And invite others to join in to discuss this with us as well. But some of the things, we really have to think about moving forward is additional research. Some of the things that both Dr. Watkins and Dr. Hunter mentioned related to the data, the exchange of information, parameters we're setting up for actual, routing and performance. For us in Sandy Springs, we're taking this information and putting together a transit signal priority plan. and have planned for the future in terms of our transportation master plan, setting aside some funding for future deployment. So that's on us. With our transit providers, there's things that they can think about in terms of retiming their corridors, looking at when's the right time for deployment, and looking at all those other factors that impact bus operations and reliability and access, down to where's the bus stop on that route. One of the things that our interns looked at really closely and thought about, and we had extensive discussions after they had gone out to look at the actual bus stop conditions. Is what does the access look like? Where is that bus stop in relation to the nearest signal and crossing? It does make a difference in transit signal priority, especially on one such as this, where you're creating zones, is whether or not the bus stop is before the signal or afterwards. So we looked through all of that. So just in terms of future research, we just had a very condensed pilot project over 6 weeks this summer and setting up for a short duration and also a small area. So really looking at other locations, looking at other improvements, looking at all of the information behind the scenes. So we are working with the technology we have, and there might be things to be tweaked with those systems as well. Again, some of the things that we learned is that we can really improve bus operations a lot if the signal timing is well coordinated. And in our circumstances, Dr. Hunter noted that maybe the combination of sort of the impacts of COVID traffic with our Scoot system meant that vehicle progression, including buses along our corridors, is pretty good right now. Again, we found out that even though our schedule and bus location information was updated every 5 seconds, it wasn't being reported out that fast. And that we also learned, again, kind of guided along by our earlier discussions in the fall talking about data, there's a lot of information that needed to be integrated together to make this all work. So just thinking about recommendations more broadly, again, TSP is just one tool. Certainly there are other opportunities to improve transit, that it's a collaborative effort. We really had a great opportunity here working with regional transit provider MARTA, our partner in City of Dunwoody with the Georgia Tech research team, and our consultant and contractor assistants. None of this would have happened, and our own TMC and transportation staff in Sandy Springs, including Caitlin and Jim. So really, we couldn't have made that work out without all of them. There are some considerations, obviously, on the local government side related to owning and maintaining and keeping up the investments. So we had the good opportunity that where we undertook this study was a fairly recent deployment of both Scoot and Glance. So, 5 years from now, we have to probably reevaluate where that heads. So in terms of the speed at which infrastructure, especially technology, is changing. So then also is, hey, what do you have out on the street, and can you leverage that technology? So with that, our kind of concluding quote, and we'd love to take some questions if you have questions about the study, about the research that was undertaken. Please put questions in the chat box, and we will field those questions with about the 10 minutes we have remaining. But this photo, if you haven't been to downtown City Springs, this is our City Springs facility with our Performing Arts Center and our City Hall, and great places to eat and dine. And the mayor was gracious enough to share a quote that, this really was a wonderful opportunity for us and gives us opportunities to partnership and work in the future to achieve our transportation goals. So thank you to everybody who participated today. And thank you everyone for joining us for this lunch and learn. I hopefully we learned a little bit more about our project and are excited about moving forward with these kind of technology improvements across the region. Thank you.
Thank you so much for that detailed presentation on all the great work that you guys did in Sandy Springs this year. At this time, I would like to post some questions from the Q&A chat box to the panelists. Please submit your questions in the chat function to be addressed by our speakers. Looks like we have one. Okay, great job. I will kick it off with a question of my own. I know you guys mentioned how you had a panel with some speakers from key stakeholders and other organizations. In your experience, what does it mean how necessary is it to make partnerships with other people? And what's that process like working with other organizations in order to make something like this happen and work across a region?
Well, I'll start and then pass it off to Dr. Watkins, but particularly just, in the Atlanta region, because we do have a number of transit providers and we have a lot of cities within counties and different service areas and responsibilities, it's a critical factor. We cannot advance this type of project forward without hand-in-hand cooperation between the transit providers and the local governments, and then our state agencies and the Georgia Department of Transportation. Just from a timing standpoint, they worked with the express bus system this past year and also did a transit signal priority pilot project and operated a different way. So there's a really interesting compare and contrast between those two studies. Dr. Watkins, do you have more to share on that?
I'll just add that I've done work in speed and reliability with transit agencies for a long time, and there's things that agencies can control themselves, right? Mike talked about, internal agency things where they were trying to get the operators to be more on time simply by telling them, be more cognizant of it, et cetera, et cetera. But you can't do something like TSP without the partnership between the city and the transit operator, right? So Sandy Springs taking on something like this where they said, we have this signal system, but they can't do it without the agency. And then, it gets bigger from there. All of these agencies sort of helping each other out by saying, here's what we learned. And if one signal system exists in this part of the region, and not throughout the whole region, but also in this other part, like you've got an easy partnership there to talk about the difficulties that you had. And so figuring out ways to gather sort of as a community where the cities are present, the agencies are present, and can talk about, here's the things we can do to make this better, as long as everyone has that common goal of improving transit so that we can actually use it more. I think literally that communication is the most important piece, Stephanie.
Thank you. And thank you for the question in the chat. We have a new question. Based on what we've learned in Sandy Springs and what other communities have in existing infrastructure, what is the expectation for portability and scalability across the Atlanta metro region and also across Georgia?
That's a big question. I might defer to our research partners a little bit on that. And also, I'm not sure, Natalie, you might have some thoughts about it. I know you've been working on some other projects as well.
Yeah, I feel like maybe Natalie could weigh in at least a little bit about, because this does relate to the implementation plan. Do you want to jump in first, Natalie?
Sure. And so I think this kind of lends itself nicely to come out of the previous kind of points that you just made about collaboration and understanding those key lessons learned and stuff. And so I think from the perspective of this particular deployment and the potential for scalability throughout the region, as we mentioned, this particular deployment leverages some existing infrastructure, those FMUs or field monitoring units that are in place throughout Sandy Springs. And there are other agencies throughout the region that have similar deployments. And so from that perspective, a methodology like this hybrid approach is very deployable or interoperable in other areas as well. In the places that might not have those field monitoring units in place, of course, it's always an option to purchase and deploy those. But there's that step of the field deployments that are necessary. And so even beyond that, I could also see a potential kind of replication from a similar type of approach once, as Dr. Hunter mentioned about MARTA having begun work on increasing or enhancing their AVL and CAD system. So once that piece of the puzzle, if you will, gets underway and refined, then I could see there being a potential opportunity, even if it wasn't the same exact FMU, to do a similar type of approach. So certainly a lot to be learned and collaborate and share across the region.
Thanks so much, Stephanie. Thank you so much, Natalie, for that answer to that question. I'm not sure that we're getting any additional questions, so we'll go ahead and wrap it up this afternoon. I want to thank the Sandy Springs team and their Georgia Tech research partners for their incredibly hard work and great implementation of this TSP alternate solution. It's great to see that there's a lot of options out there with different various technologies, and it's good to hear that there are other communities that are implementing different technologies that now we can kind of do a comparison side by side and push this technology forward. So again, really excited that you were able to attend this afternoon. I do ask that you please check out our 3 additional final presentations from our 3 other Georgia Smart Communities Challenge partners. They will be September 16th, Clayton County, again here Thursdays at noon. Valdosta will be presenting on September 23rd. And finally, the city of Savannah will be presenting their final presentation on October 14th. So thank you all, and I'll hand it back to Stephanie real quick to wrap it up for us.
Thank you, Greg. Thank you to our Sandy Springs team and researchers, and thank you all so much for joining us today. We look forward to welcoming the other 2020 Georgia Smart Communities for their final presentations this month and next. You can always visit our website, pingeorgia.org, for more information about all of our upcoming webinars this fall. Thank you and have a wonderful day.